Imagine every picture you took over the past year, all saved within the area of a single dot of ink from a ballpoint pen. Well, this is approximately how compact data is stored inside a hard disk drive. And in this video, we're going to open one up and see how an entire library worth of books is able to fit within the surface of this metal disk. We'll start by opening up this hard drive and detailing the components inside. After that, we'll dive into exactly how the drive stores data using the read and write head, and in the process, we'll look at the tracks, sectors, and magnetic domains of the metal disk. Finally, we'll explore some of the latest advances that enable over a terabit of data to fit within every square inch of the disk. This video is sponsored by PCBWay. More on them later, but for now, let's jump right in. On the inside of this drive, we find a variety of components. Here's the disk, or platter, that stores all the data, and depending on the storage capacity of the drive, might be multiple platters tall. The disk is composed of an aluminum-magnesium alloy with multiple coatings of other alloys, but the magnetic functional layer is this 120 nanometer thin layer of a cobalt-chromium-tantalum alloy, which has small magnetic domains or regions whose direction can be manipulated via external magnetic fields. The platter is mounted on a spindle which spins at a speed of 7,200 RPM, using a brushless DC motor at its center. Next, there's a head stack assembly, with one arm above and one arm below each disk, and with a slider and a read-write head at the end of each arm. The slider is uniquely designed such that it catches the airflow generated by the ludicrously fast-spinning disk and uses the airflow to float or fly the read-write head so that it's only 15 nanometers or about 100 atoms away from the surface of the disk. For reference, here's the thickness of a sheet of aluminum foil. Because the arm assembly flies on top of the spinning disk, it's only brought over the surface when it's at full speed. And when the disk is not spinning, the arm assembly is parked to the side on a small piece of plastic. Back here, a voice coil motor composed of a coil of wire and two strong neodymium magnets above and below is used to move the entire arm stack assembly. When electric current is run through the coil, it creates an electromagnet, which is influenced by the neodymium magnets, thus generating a force that causes the arm to move across the disk. When a reverse current is sent through the voice coil, the arm is forced in the opposite direction, thereby enabling control of the exact position of the read-write head within 30 or so nanometers. Additionally, the magnets and voice coil make a rather strong motor that enable the lightweight arm stack assembly and read-write head to move back and forth to different tracks across the platter up to 20 times a second and to make small adjustments incredibly fast. In order to connect to the read-write head, a flexible ribbon of wires is routed along the side of the arm and down to this connector, which feeds signals to the outside of the hard drive enclosure and to the printed circuit board or PCB. On the PCB, we have the main processor, as well as a DRAM chip, which is used as a scratch pad for the processor and a buffer for the incoming and outgoing data. Additionally, mounted on the PCB is a chip for controlling the voice coil and brushless DC spindle motor. And then on the edge of the PCB is a SATA connector, which connects to the motherboard for communications, and a separate connector which goes to the power supply. Additional important components are the gasket that seals the disk from the exterior environment and two filters that catch any stray dust particles. These filters are necessary since the read-write heads are just 15 nanometers away from the platter, and a single dust particle can be up to 10,000 nanometers large and could cause major damage if it were to collide with the 7,200 RPM disk. Now that we've looked through many of these components, let's see how they work. To begin, the disk is divided into concentric circles of tracks. The latest hard drives can have more than 500,000 tracks on just one side. These tracks are then divided into sectors, And in each sector is a preamble or synchronization zone, which tells the read-write head the exact speed of the spinning disk and the length of each bit of data. The next part of the sector is the address, which helps the read-write head know which track and sector it's currently positioned over. After that, we have the actual data that's stored, typically 4 kilobytes of data per sector. Next is an area for an error correcting code, or ECC, which is used to verify that the data stored in the block is accurately written and properly read. And finally, there's a gap between this sector and the next, which allows the read-write head some tolerance when writing the contents of a block.